In an era of accelerated globalization, the transportation and logistics sector is of vital importance for supporting world connectivity and nations' competitiveness. Every day, we consume products that come from the most different places in the world. Before you can buy them in the supermarket close to you, goods travel thousands of kilometers from where they are produced to where they are consumed. Every year, millions of tons of goods transit all over the world in sea containers. The port of Rotterdam, for example, receives about 30,000 ships per year, carrying more than 450 million tons of food, tobacco, medicine and consumer products. Providing a reliable and efficient logistic chain for cargo transportation is of fundamental importance to ensure that the cargo reaches the final destination safe, securely and on time. In order to meet such requirements, specific technological solutions can be properly conceived for the logistic industry, so to enable complete control over the entire transportation process. A smart container enhances the current monitoring solutions, in order to facilitate a more automated and reactive decision-making process. By equipping the container with diverse kinds of sensors and actuators, it is possible to ensure a continuous and possibly real-time tracking system, capable of measuring and reporting the cargo conditions during the whole trip. But not always such a trip ends as planned. Cargo can go bad, and the sooner and the more reliable we know about that, the better we can deal with the consequences. DEMANES is an Artemis European project that uses embedded networks to improve the way we measure and control the world around us. A group of scientists of the DEMANES project are finding out ways of monitoring the state of the cargo during any phase of this long trip, and they want to use a powerful weapon, adaptive embedded systems.
Network embedded systems such as these, with their unique distributed sensing, communication and computing capabilities, offer effective solutions to monitor events of interest occurring in a remote area. We intend to use this type of systems to observe the cargo state in real time. By monitoring inside the container or outside the container, parked on the ship or in the cargo terminal, it is possible to follow the shipment from the supplier to the client.
In nature, adaptation is key to survival. Some examples are the chameleon, which can change its color according to the environment, or a stingray that has a flattened body shape that aids in hiding in the sand and mud underwater.
As engineers and researchers, we look to nature to develop self-adaptive systems capable of recognizing the environment and understanding it. This way, they can react to the changes and provide a better way to save energy and keep the communication alive.
By designing an application with adaptivity in mind, we can more effectively build systems that are aware of their surroundings and know how to react when unexpected things happen. Using this technology, the cargo supplier can rely on the cargo monitoring system to continue operating under a wide variety of circumstances. For a client, it's very important to know that the shipment arrives in top condition. TNO and TU Delft developed these sensor boxes that contain an adaptive networked embedded system and different sensors to cooperatively monitor their environment. In order to maintain an accurate estimate of the cargo state, we use smart algorithms to keep track of the cargo's temperature and humidity. In order to balance the accurate measurements and the battery consumption, an intelligent piece of software adapts the system's behavior so that it would become more responsive when circumstances require more timely information. When an unexpected event occurs, such as a sudden increase in the observed temperature, the sensor boxes switch to an increased awareness mode to get information to the client more quickly. Conversely, if a node's battery drains more quickly than expected, it will change to a profile requiring less energy. Running application based on the DEMANES middleware, we allow system developers to write applications that can adapt their behavior while maintaining a low overhead on the devices.
The cargo monitoring system must be 100% reliable in all weather conditions. Ships and the cargo container operate in a harsh condition. Therefore, it is often the case that uncertainty in the propagation medium plays a disruptive role in the normal operation of the sensor network. Having a reliable communication over a wireless network is a challenging task. Even more if low energy consumption is a requirement that should be kept into consideration. And this is particularly true for the embedded network system deployed in our cargo monitoring pilot, where continuous operation during the container's long trips should be guaranteed in spite of the limited battery powered devices. Since the radio transceiver is the most energy consuming component of such devices, we from the Technical University of Eindhoven are tackling this challenge by providing solutions based on self-adaptive transmission power control. The technique developed for DEMANES can reduce the overall energy consumption of the inter-container network and yet ensure high performance in terms of latency and data delivery.
Have you ever heard about the social theory known as 6 degrees of separation? This theory says that everyone is 6 or fewer steps away from any other person in the world. At the Technical University of Madrid, we are exploring a similar theory applied to wireless sensor networks. We believe that in a mesh wireless sensor network, every device can keep a reliable communication with any other device in the same network, just by keeping a small amount of neighbors. As you can see, we are translating the number of steps or hops in a network to the number of neighbors. Why are we doing this? Imagine that using the 6 degrees theory, you try to send a message to Will Smith, but instead of choosing just one person as a first step, you shout out to all your surrounding friends so that they can know about your interest to contact Mr. Smith. And upon receiving your message, they also shout again and again and again until the message reaches its final destination. Instead of wasting energy by putting maximum effort in spreading the message to all possible neighbors, by setting the number of neighbors to a value related to the network density, we can achieve the reduction of the total network power consumption while keeping the reliability of the network. This self-adapted control algorithm has been implemented using the DEMANES middleware to provide the reasoning capabilities to decide whether or not to improve the transmission power. In the cargo monitoring demonstration, we test this using sensors deployed outside the container. They can be monitoring conditions of a storage facility, a cargo ship, and so on. The sensor network serves also as a relay network when data communication from one container to the client is not possible.